a cylinder that will hold as much stuff as possible. He has $400 to spend on making this cylinder. The sides of the cylinder cost $2 per square foot, and the top and bottom of the cylinder cost $6 per square foot. What should be the dimensions of the cylinder to maximize the volume? So the volume formula is pi r squared times height. And as I look at that, I see there's 3 variables. I'd rather only have 2 variables, but this is what we're trying to maximize. And in order to maximize it, we're going to take a derivative and see where that derivative changes from positive to negative. Because if the derivative was positive, that means the function, the volume, was increasing. The derivative is negative, that means the function was decreasing. And wherever the derivative goes from positive to negative would give us a maximum. So this is eventually going to be a derivative. We'll set it equal to 0 and see where does the derivative change from positive to negative. The other thing we have is the constraint. We're looking at the cost as $400. So I know that the cost has to be equal to $400. If I want to maximize the size, I'm going to use all 400 of the dollars. The cost is going to be the area times the cost per square foot. So 2 pi RH, this is considered the lateral area. So if I'm looking at my cylinder, the 2 pi RH is this part times the $2 per square foot. So this is the cost for the lateral area plus 2 pi r squared. This is the area of the top and the area of the bottom. The top is pi r squared. The bottom is pi r squared. So the area of the top and the bottom times 6 because it's $6 per square foot for that. So here is our cost equation. This is what I know to be true. I can plug 400 in for C. Multiply a little bit. That's 4 pi RH plus 12 pi r squared. And again, this equation is true. I'm not trying to minimize or maximize anything with this constraint, with the thing that I know. So I'm not taking a derivative. What I am going to do is try to solve this equation for one of my variables. I could try to solve it for r, but there's an r and an r squared. Getting r by itself is going to be way more difficult than trying to get h by itself. So a little bit of algebra. Let's say we subtract 12 pi r squared from both sides. And that leaves us with 4 pi RH on the right. I don't want the 4 pi r there. I want to have h by itself. So we're going to divide both sides by that 4 pi r to get the h is equal to this. Now we know h is equal to. Let's plug it in over here. So volume equals pi r squared times h. I know this green equation looks a lot more difficult than the blue one that was above it, but the better thing about this green compared to the blue is that this green equation on the right side only has the variable of r. That's going to be a lot easier to do our derivative with. And I can simplify down a little bit. This pi r squared is supposed to distribute to both of the terms in the numerator, but I see that both of these terms in the numerator are also divided by this, so I can cancel out pi and pi. I can also divide this denominator by r, divide that by r. So really the only thing that's happening here from the green to what I'm going to write in black is that this r is going to distribute 400r minus 12 pi r cubed over 4. And again, I want to take a derivative of this. Before I take the derivative, why not simplify it just a little bit more? In other words, on that right-hand side, divide both of those terms by 4. And then this equation looks pretty manageable. So we can take the derivative of this one at this point. So v prime is equal to 100 minus 9 pi r squared. That's the derivative. That's the rate of change of this volume. And if I think back to the original problem, I don't know what this original graph would look like, but if its derivative changes from positive to negative, that means that the function was increasing, then the function was decreasing. That should give us a maximum, and we're trying to maximize. I could do some algebra on this one, set it equal to 0. So 0 equals 100 minus 9 pi r squared. Add 9 pi r squared to both sides. We're just going to do some algebra to solve this equation for r. Divide both sides by 9 pi, and then take the square root. So here is my r value, my radius. I can use my calculator to get a decimal for that. But one thing I don't know for sure is that even though if I plug r back in for this derivative, the value should be equal to 0. That's good. But how do I know this is a maximum and not a minimum? Well, if I check v prime, I'm going to do some approximating here. 100 divided by, let's see, 9 times pi is about 27. 100 divided by, let's say I call that 25, because 100 divided by 25 is 4. Square root of 4 is 2. So this is somewhere around 2. I know that's really a big estimation, but it's somewhere around 2. So 0, here is this r value that I think is going to give me a maximum. And I can try something something smaller than 2, like something just barely bigger than 0, plug it into my derivative. So I'm plugging in a really small number here, squaring it times pi times 9, 100 minus that. My mental math tells me that's going to be something positive. Essentially, I take a really small number, just barely bigger than 0 because it's in this region. So I'm really doing 100 minus 0. That's a positive value. Now, if I take any big number over here, a number bigger than 2, let's go really big. Like let's call it like 100. That's definitely in this range over here. 100 squared times pi times 9, and then 100 minus this number. This number is going to be much bigger. 100 minus the bigger number gives us a negative. So what I'm seeing here is, since this derivative is 0, and this is the only place where our derivative is going to be equal to 0, there's a plus minus, there's a negative one, but that wouldn't make any sense. So this is the only place where the derivative equals 0. So the derivative was positive and then negative, which tells me that this is going to be a maximum. No, this problem is not a theoretical problem. It is a problem with words in it and so forth. It has context and so forth. So at this point, what I'd recommend is go to your calculator, figure out what decimal this is. Take the square root of 100 divided by 9 pi. That will give you your r value. Once you know that, you can plug that in up here to get your h value for your height. That will give you the dimensions to maximize the volume then. So you can compare those numbers with what I got when I did my calculations. I got a radius of just slightly less than 2, and the height is a little bit bigger than 11. So 1.881 for my radius, height of 11.284 feet. And that will maximize the volume of our cylinder.